This video will be about compound interest rate. Definition. Compound interest is interest you earn on both your original amount and interest that builds over time. It is very different from simple interest rate. Here's the formula. Total amount is equal to principal parentheses 1 plus r divided by n, close parentheses, to the n times t power. And of course, A is the total amount after interest. P is defined as the principal or starting investment. R is annual interest rate in decimal form. N is the number of times interest is compounded per year. And T is the time in years. Example 1. Josh has to choose if he wants to invest in $5,000 with a compound interest rate of 3.5% annually for 10 years, or if he wants to invest $4,500 with a compound interest rate of 3.75% monthly for 10 years. So first choice, we will figure out how much he will earn after 10 years. And of course, there's our formula. A is equal to P parentheses 1 plus R over N, close parentheses, to the N times T power. And of course, we substitute our values in. We get A is equal to 5,000 times parentheses 1 plus 0.035 divided by 1, close parentheses, to the power of 10 times 1. And then we do all the math. Of course, we do the what's in parentheses first, and then we take it to the 10th power, and then times whatever that answer is, times 5,000, which we come up with $7,052.99. In our second choice, we use the same formula. This time we do 4,500 times parentheses 1 plus 0.0375 divided by 12, close parentheses, to the 12 times 10 power. And after doing all that, we get $6,543.63. And so we find out how much interest Josh would make on each. And the first choice, $7,052.99 minus $5,000 is equal to $2,052.99 interest. The second choice, $6,543.63 minus $4,500 is equal to $2,043.63 interest. And so by a little more than $9, the first choice would be a better choice for Josh. And of course, as you could see, how many times per year the compound interest rate works will also benefit to more money, as you could see in the second choice. But since we invested $500 more in the first choice, then that ended up being a better deal as far as getting more interest. Example 2 says Janet plans on investing $20,000 of her money Big Dollar Bank, of course it's a fictitious bank, has two choices for her. Option A is a compound interest account at 5.2% compounded quarterly for 5 years. Or option B is a compound interest account at 5.3% compounded annually for 5 years. Which option is better for Janet? And of course, we'll do, using our compound interest rate formula, we'll do option A, and then we plug those values in. $20,000 times parentheses 1 plus 0.052 divided by 4, close parentheses, to the 4 times 5th power. And of course we used the 4 because it said compounded quarterly, so that's 4 times each year. And so then we end up with 20,000 times 1.013 to the 20th power, and that is $25,895.18 for option A, the total amount. Now option B, we use the same compound interest rate formula, and we do $20,000 times parentheses 1 plus 0.053 divided by 1, close parentheses, 1 times 5, the power. And then we end up with 20,000 times 1.053 to the 5th power. And so all that comes out to $25,892.37 for option B. And so in conclusion, despite the interest rate being a little bit higher for option B, option A was compounded 4 times each year, which made this a better choice for Janet by, looks like, almost $3. Compound interest rate versus simple interest rate. Which one is better? We'll find out. Option 1, $10,000 simple interest rate at 5% for 10 years. Or option 2, $10,000 compound interest rate at 5% annually for 10 years. So option 1, simple interest rate formula is I equal to P times R times T. Of course, I stands for interest, P stands for principal, R stands for rate in decimal form, and then T stands for time in years. So I is equal to $10,000 times 0.05 times 10. And in this case, I is equal to $5,000, which makes this a total of $15,000 for option 1 after 10 years, the total amount. Option 2, we'll use the compound interest rate formula. And so we'll plug in $10,000 for principal, 0.05 for rate, and then 10 for time. And as you can see, that's our substitution rate. And then all that calculated is $16,288.95 for option 2. So it's clear which choice is a better choice. And it says clearly, with the interest rate being the same, compound interest rate earns a lot more interest, which makes option 2 a better choice by $1,288.95 over a 10-year period. So in conclusion, compound interest rate earns more interest versus simple interest rate if rate, time, and principal are the same for both. The more times per year compound interest rate is, the more value it will earn in interest. And for example, let's say compound interest rate will earn more interest if the rate was compounded monthly versus if the rate was compounded quarterly, assuming the rate, principal, and time are the same. And banks will use both compound and simple interest rates for loans, savings, or interest-earning checking accounts. Thank you for watching, and if you find this video helpful, please like and subscribe, and have a nice day.